Hello again. This time I wanted to go over some of the multiplication methods that we teach the kids how to do. So, I know I've said it in the other videos, but Mrs. Murphy has pictures of each of these things up on the Facebook page. You may have to scroll down a little bit because they're on the school's Facebook page, and every time it updates they get bumped down a little bit. But it might be nice to have a still version of these so that you can see what they are, but I thought it'd be helpful to understand what the pictures were if I did one live for you. So I made up a different problem than she has up on there. I did 15 times 32. So once again, we have 4 methods that we really teach the kids to go with. The primary one we teach them is still the traditional method, the way that you and I were taught once upon forever ago. So in doing that, you could stack them either way, but I know the brain of a 10-year-old, and they would say, nah, put the 32 on top because it's bigger, which is fine. It doesn't really matter the order. So I would go through and say 2 groups of 5 is 10. So I'm going to end up carrying that 10. 5 times 30, because that is not a 3, it's a 30, is 150. Add on that 10 is 160, which is why it looks like the 160 now. And then I've said it in a few videos, but this 1 isn't a 1, it's a 10, which is why we put in that placeholder. And then after that, you just finish off the multiplication, put that down there, add them up, 480. On paper, that's the way most of the kids will go. But since we are working on mental math in the other 3 groups, sometimes the methods look a little bit different, but they're pretty similar to things that we do in our own heads when we start doing work. So the other one the kids really like is partial products. This one is pretty close to partial sums that we did with addition, but since we're multiplying, it's not sums anymore, it's products. But I'm still going to look at things in their place value parts. And to do that, some of the kids call this the box method because we end up drawing it in a box. But you take that, and I'm going to split this up into place value parts. Since each of these has 2 place values, they get a box. That 15 is, we're going to call 10 and 5 because that still makes 15, but they're in their place values. And 32 we're going to call 30 and 2. After that, it's just multiplying whatever parts fit in that box. So like here would be 10 times 30, which is 300. Because of the rules of multiplying with tens, I know that I'm looking at 1 times 3 is 3, and then 2 zeros, 300. 2 sets of 10 is 20. Down here, I'm now looking at it with the 5, not the 10. And 5 times 30 is 150. And 5 times 2 is 10. After that, it's just putting all those pieces together. So I have 300, 150, 20, and 10. Add all those up. 0, 8, 4, 480. Okay, so there's those 2. Like I said, these are probably the 2 most common choices. This one for paper and this one for in their head. Another option that we teach them is called compensation. And in that method, we're really just going to adjust this problem to something that I actually would rather do in my head, and then adjust the problem back so it still represents that same value. So on this one, I'm not super excited about multiplying with a 2-digit by 2-digit, but if I changed this so that it looked like 30, I'd be a lot happier because I know how to multiply with tens pretty fast. So I'm going to call that 15 times 30, which comes out 5 times 3 is 45. Add on the 0, 450. But in this case, I had taken away 2 groups of that 15. So I actually need to put back that extra, or those extra groups of 15 that I'd taken away right here. So I'm going to do 15 times 2 and put that back in there. Gave me 30 back, making my 480. And the last method is called decomposing, where we kind of split the numbers up into something that we like a little bit better, and then put them back together to make that answer at the end. So I have 15 times 32, and I can split these however I want. It doesn't matter which way I grab them, which number I manipulate. It doesn't matter as long as in the end they still say that same value. So I don't like multiplying by 32s, but I am pretty good at multiplying by 15. So I'm going to call this 30 and 2 times 15. In this case, it kind of ends up like this one. The difference is here I could choose whatever I want. So I'm going to do 30 times 15 and 15 times 2, which gives me 30 for this problem. And 450, oops, sorry, I didn't line those up very well. That should have been over there more. And you get 480. Okay, this will help you for the next few weeks with the kids as they're working on multiplication problems and the problems are getting a little bit harder. I wanted you to have this to help you out. Have a great day.